Good afternoon, everyone. Good afternoon. Ploy, hello. How are you today?
I'm fine, teacher.
That's good. That's good. Your brother? How old is your brother?
He's fine.
Hello.
Hello. How are you
Hello.
today?
I'm fine.
That's good. That's good. Ken is also coming. Okay. Hello, idea. How are you today? Who is relaxing in your background? Paul. Okay.
Hello, teacher Tony.
Hello, how are you today?
I'm fine.
That's good. That's good. Hello, Saya. Saya, hello, how are you today? Okay, wait a minute too. We come today on a new chapter. The chapter is called Matter. So we go it slow on today, same as example. Idea is eating ice cream. Ice cream is a state of matter. Can you remember the state of matter idea? What is ice cream? Ice cream is frozen water as example. So frozen is a state of matter. So we say there are changes in matter. So I make open our screen share and go on the desktop. Okay. So now you can see the book if I am right. Can you see the book, Heidi?
Yes.
Okay. So we started slow today. For first, we need to understand what is the meaning of matter. Matter is everything around us, what we can see or what we can feel, as example. What are things we cannot see, but it still matter? What do you think? What you can see, but you can feel it? Heidi, what is it? What can you feel, but you cannot see it? Easy. You can feel it, but you cannot see it. What could it be? Keep mark. Okay, I give you an idea more. Okay. If you don't have it, you die. What is it? You cannot see it, but you can feel it. If you don't have it, you're gonna die. What could it be? Kid mark. Okay, anyone can give me an answer. You cannot see it. Say again. I hear more your background than I hear what you say, MJ. Air, correct. Air for breathing. You cannot see it, but you can feel it. Same when you have a fan and the fan blow air to you, then you can feel the air. So you cannot see it, you can feel it, but if you don't have it, you're gonna die. So air is also a matter. So all around us is matter. matter means things, as example, like water, like stones, like iron. Everything around us is matter. So what is matter? Matter, we have to understand first when we take it under a microscope. Everybody know what is a microscope, right? Idea, you know what is a microscope? Idea? Idea is quiet. Ploy, I can see your cam. Do you know what is a microscope? No. Okay. If you don't know what is a microscope, we take Google. Google can show us everything. Microscope, here you go. Here, a microscope. Now you know what is a microscope, okay? So a microscope can make something small so we can see it bigger. So, but for make something so small, so big, we need a special microscope, not just a microscope that we have here, where we can see something as example 1,000 times or the 2,000 times bigger. We have to get much, 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 much smaller. Who can tell me, if I take an apple and you cut this apple into slices and cut it smaller and cut it smaller, where is the point you cannot cut smaller, what you get out? Who can tell me what you get out, you cannot cut smaller? This here. Atoms. Everybody.
Crumbs.
Atoms. So the smallest thing in matter is the atom. Same as example, we have, I show you that in Google. Ow. Oh, this is wrong. This is not the right one. So wait. Okay, now. The periodic table. The periodic table, it means everything is like a recipe. Everyone know what is a recipe, right? You like to bake a cake, you like to making cookies, you need a recipe, and the recipe has different ingredients. So this here is a table where you can see all atoms, what we know. So all atoms like gold, like oxygen, nitrogen, carbon. So everything around us is made out of atoms. Yourself is made out of atoms. So this here's example is the smallest part in our matter. So we have here's example, we have oxygen, or as example here, we have hydrogen. So if I take as example oxygen and hydrogen and mix this together, I say mix. It's not so simple, but okay, you know what I mean. If I take oxygen and hydrogen, these two, and mix it together, what do I get? Who can tell me? Oxygen and hydrogen mixed together, what do I get? Who can tell me? Who can tell me? Anyone? Let's see. I am 100% sure when I write something, then you know what it is. So I make this bigger for now. I make this bigger. How? But I cannot make it bigger like that. Ah, okay, I know how. So now, okay. So I write something and then you guess what it is. What is that? Did you ever see that? H2O. What does it mean? H2O. Cannot be new. Cannot be new. I think you saw this. Water. Very good. Very good. But why do we say H2O? So same as example in the picture, we see hydrogen. We say here as example, oxygen. So when I take as example, 2 hydrogen and 1 oxygen, oops, wait. 2 hydrogen and 1 oxygen, then I get out water. Same as example here is 1 atom oxygen, 2 atom hydrogen, and I get out water. So the result of this is water. So everything has a recipe. So as example, we have here is a recipe for sugar. In sugar, the red one is oxygen, the white one is hydrogen, and the black one is carbon. And they are mixed together. I say it's more mixed together, and they give sugar. So I can make with hydrogen and oxygen, I can make water. With hydrogen, oxygen, and carbon, I can make sugar. So all our surrounding, everything around us is made out of atoms. When it's something mixed together already, then we say molecules. So molecule, atom. Atom is the simple ingredient, and the molecule is the cookie as example. So we have there many different as example here. This everybody know, CO2. What does it mean, CO2? What does it mean?
Carbon dioxide.
Very good, very good. Carbon dioxide. So now in the middle, we have 1 carbon, and outside we have 2 oxygen. So both mixed together is the molecule carbon dioxide. Carbon dioxide. This here's example is sugar. This here's example is water. So everything has one ingredient, or everything has an ingredient. As example here, hydrogen and oxygen. And if I mix this together, I get different things. Same you make as example. You take the same ingredient, you make a chocolate cake. You take the same ingredient, you make a chocolate cookie. So you can make different things out of these ingredients. Same as example, okay, I take milk, egg, and sugar. What you can make out of that? Let me see. Milk, egg, and sugar. What you can make out of that? Heidi is still eating. What are you eating, Heidi? No problem. Say it. Mama. You eat mama?
Banana cake.
A banana cake. Okay. Oh, we are already by the cake now. So what you need for a banana cake? You need eggs. You need flour. You need water. You need sugar. So all of these ingredients, you can make different cakes out. So the same is the atom. Don't think something too difficult. See as example, 1 atom as eggs. Another atom you see as flour. Another atom you see as milk. So you can make from these different atoms, you can make many different things out of it. So the problem is what is many times people see things too difficult. So we have there as example, the changes in matter. The changes in matter is also very difficult, but if we see it with easy eyes, then we can understand it more easy. So the changes in matter has to do with 2 things. Pressure and temperature. So now when you see as example, the calling the calling of the names. So we have there as example, the two different things, the changes matter into different state of matter. So as an example here, we have pressure and then temperature. We spell it different, but when you hear the word in English, pressure, temperature, then you have the same meaning, the same hearing, temperature, pressure. Pressure means press something, push something very hard. So it's there, the pressure. The temperature is everything about hot and cold. So every one of you, I think, as example, okay, Heidi, when you drink a bottle of water, a small bottle of water, and you drink this small bottle of water half finish, and then the water is warm, is ไม่อร่อยใช่ไหม warm water อร่อยไหม ไม่อร่อยเหรอใช่ so you take this half full bottle water, you put in the refrigerator for an hour, then you have cold again. But what does change? What is the change in the bottle? So the bottle gets soft. When you put it in the refrigerator, the bottle looks like okay, but when you take it out from the refrigerator, the bottle looks different because the air in the pressure, the air in the bottle gets smaller. So we have there the temperature. Same, I go again on the picture for you see the picture again as example in water. You see here around the molecules, you see a lot of space. And this is what everything made out of. Your body, your table, everything around you is made out of space. Space means nothing around it. There is nothing. Here is nothing. Here we have one molecule and here is nothing. So when I take as example, I take it, wait, I make a drawing. Okay, here we go. So all around here, there is nothing. Okay, there is nothing. So when I have as example, change the temperature, I make something hotter. So when I make water hotter, what is going to happen when I make it hot? What is going to happen? You cook water. What happens?
Vapor comes out.
Correct, steam. So that means, as example, the space between the molecules gets bigger. Sorry, I cannot good draw with my mouse. The space between the molecules gets bigger and bigger and bigger. If you take as example, heat the water in a bottle, make this bottle close, and heat the water up more and more and more, it will make boom because it needs more space. So here the space goes bigger and bigger. When I make it colder, as example, here we have hotter. Oh, why I cannot see my letters? Because it is white. Why? How I can change the color? Red. Okay. Hotter need more space. Hotter need more space. Okay. So when I make something colder and colder, then it needs less space till it goes into what? Into what? When I need more or less and more or less space between here, between the molecules, same as example, I take, where is now the pen? Yeah, I don't know this menu here. Spotlight, tick, draw. Okay, here's the drawing. Okay. No, here. So now I go there and say there, okay, I have a hotter the space goes bigger. But when I make it colder, then the space between this both gets smaller and smaller and smaller till it is solid. So we have 3 states of matter. 3 states of matter. So clean this quick up, clear the drawings. All drawings, okay. Go out. Just a moment. Now, okay. So we have 3 different states of matter. When we go in our book, the physical stages of matter, we have here as example, ice. What is ice for a matter? Everybody know ice is water, but what state of matter is ice? Who can tell me? We have 3 different states of matter.
Solid.
Solid, correct. Solid, liquid, and Heidi, what's the third one?
Liquid.
Oh, say again. Solid, liquid, and solid, liquid, and
Gas.
gas, correct. Solid, liquid, and gas. You must think so, all things around us, so not the egg. The egg I cannot make from I can make an egg from liquid to solid, but I cannot make it opposite from solid to liquid, because here it's not a physical change, it's a chemical change. So we have there the cooking of food is a chemical change, not a physical change. So solid, liquid, and gas we call their physical change. So now we have here as example, I show you a short video where you can see temperature change a gas into liquid. So I just have to first sound share on and come go open video. Okay, just a moment. I must start the video.
Liquid oxygen with just a bag.
Okay. So you see here someone, he will make from air in the room, he will make liquid. Can you hear the sound when I make the sound open? Only first of all check.
Okay, today I'm going to be showing you how you can make liquid air and even liquid oxygen.
Can you hear the sound?
Yes, teacher.
Okay, good. Enjoy the video, it's fun.
With just a bag, a test tube, and some liquid nitrogen. So today I'm going to be turning this bag of air into a liquid. So liquid nitrogen boils at around -196 Celsius, but liquid oxygen boils at a -183 degrees Celsius. And so what that means is that you can liquefy oxygen using liquid nitrogen. So you could do this if you had some compressed oxygen. You could run it through this liquid nitrogen in a tube and it would condense out of it. But I'm going to show you the simple, easy way to do it. And that's just to get a bag, fill it with air. That just means going like this. And then connecting it to a test tube. And then I'm going to put the test tube in the liquid nitrogen and it's going to start condensing the air out of the bag and it's going to fall into the bottom of the test tube here and you'll see some liquid air start to accumulate at the bottom. And then once we take that out, if you let it sit for a while, the liquid nitrogen will boil off first, leaving behind just liquid oxygen. So I'll stick my test tube in it and we should see some liquid start to form at the bottom there eventually. It's going to condense the oxygen out of here. It's also going to condense the nitrogen out of there. It's going to freeze the carbon dioxide that's in the air and make it a solid. And it's going to freeze the water that's in the air and also make it a solid. So you can see the liquid at the bottom there. A little bit hard to see in the cup, but so as this bag continues to cool, the volume of it is getting smaller and smaller and smaller until eventually all that volume in the bag is going to be this tiny bit of liquid at the bottom there. Okay, you can see the liquid air at the bottom of the test tube in the liquid nitrogen. If I take it out, it'll quickly frost up, so I'm leaving it in there. So that is liquid oxygen, liquid nitrogen, and I don't see any solid yet, but there should be a little bit of solid in there that's carbon dioxide. Okay, it's looking good now. Look how much liquid air we have in there. It's a lot. The volume of our bag is about half of the initial volume it was before. Okay, here's my final liquid air in here. So you can see what happens when I pour it on this fire here. The fire can keep burning. It boiled before it even went. You can tell that that was liquid air going in. It had oxygen with it, so the fire could keep burning. For example, if I pour just the liquid nitrogen on it, it immediately goes out, even before the liquid gets there. Hey, thanks for watching another episode. I hope you enjoyed this video. If you're not...
Okay. So we are back. So you see temperature, the temperature cool the air so much down for the molecules get so close to each other for it become liquid. Okay, I make sure the sharing off. So I see you again. Okay, now we go. Okay, Heidi, did you understand the video? Liquid nitrogen is very, very, very cold. So you must think nearly 200 degrees minus. When you have your refrigerator where you make ice in there, the refrigerator, a good refrigerator has about 15 degrees minus. So the liquid nitrogen is about close to 200 degrees minus. So in this temperature, the air goes into liquid. There's no gas anymore there. So all the gas in the plastic bag, so all this air in the plastic bag shrink smaller and smaller because the space between the molecule becomes smaller. Same, you saw it before in the picture. And then after it came into solid, into liquid, into like a water. So if I would cool it more down, what I cannot do, but if I would cool it more down, then the oxygen and the nitrogen and everything became solid. So everything around us, the natural materials, what we get out from the soil, as example, iron. Iron, as example, I can make liquid iron. What do you think? How many degrees do you need, MJ, for you make from iron what is solid, liquid? What do you think? How many degrees do you need?
90 degrees.
90 degrees is water. So you can melt iron, you need about 1,500 degrees. Then the iron become liquid. If I like to make iron into gas, I need 3,000 degrees. So I make something hot or the cold, it changes the matter of the surroundings. So why we say, as example, air is a matter? Why do we say that? Air is also a gas. So as example, we have nitrogen in there, we have oxygen in there. So I will show you a very interesting video. And okay, do you know what is a feather? Okay. Do you know what is a feather? Everybody know what is a feather, okay? Heidi, do you know? You know what is a feather, right? Okay. So, and do you know what is this here? Do you know that?
Yes, teacher.
It's a bowling ball. So we have there a bowling ball and we have a feather. So if I take as example a bowling ball on one hand, a feather on the other hand, and both I let fall on the floor. Which is first on the floor? The bowling ball or the feather?
The bowling ball.
The bowling ball. So you say the bowling ball is first on the floor and then after the bowling ball come the feather on the floor, right? Right? Okay. Now my question. Now my question. Okay. I ask also Heidi, I ask Idea, I ask everyone. Why the bowling ball is faster on the floor as the feather? Why? Why the bowling ball is faster on the floor than the feather? So why the feather is slower than the bowling ball? So again, we have here the feather. We have a feather in the hand. We let it falling. The same time, we let the bowling ball falling on the floor and the bowling ball land first on the floor. But my question is, why? Why the bowling ball is faster on the floor than the feather? Why the bowling ball fell faster than the feather? Why? Who can tell me? What do you think?
Because the bowling ball is heavy.
Okay, MJ say because the bowling ball is heavier. Okay, what do you say, Heidi?
Round.
Same, because the bowling ball is heavier than the feather, so the bowling ball fell faster. Okay, how about you, Idea? What do you think? Ploy. Bowling ball, feather. Bowling ball is heavier, feather is lighter. So you think, who think because the bowling ball is heavier? Who think that? Do you all think that? Okay.
And round.
Okay, I can show you something. But okay, first we make a restart with our time because our time 40 minutes is soon over. We restart our Zoom and then I show you, okay? So I make sure the one off. Restart everybody, okay? Restart.